Explore the most mysterious and powerful objects in the universe, black holes. A black hole is a region in space where gravity is so strong that nothing, not even light, can escape from it. Black holes form when massive stars die in spectacular cosmic events. When a massive star at least 20 times the mass of our Sun runs out of nuclear fuel, it can no longer support itself against gravity. This is a massive star in its final stages, radiating enormous amounts of energy. The star collapses inward catastrophically, compressing all its mass into an incredibly tiny space. The core collapses into what we call a singularity, a point of infinite density, where normal physics breaks down. The process goes from massive star, through a supernova explosion, to the formation of a black hole. The event horizon is the point of no return around a black hole. The event horizon is the boundary around a black hole beyond which nothing can escape, not even light. The event horizon is the boundary marked in pink, with the singularity at the center. The radius is called the Schwarzschild radius. The Schwarzschild radius equals 2gm over c squared, where g is the gravitational constant, m is the mass, and c is the speed of light. Once anything crosses the event horizon, it is forever trapped inside the black hole, with no possibility of escape. Black holes create extreme warping of spacetime. According to Einstein's general relativity, gravity is not a force, but rather the curvature of spacetime caused by mass. This is flat spacetime represented as a grid. In the absence of mass, spacetime is flat and uniform. Near a black hole, spacetime curves dramatically, creating a deep gravitational well that traps everything nearby. The more massive an object, the deeper the curve it creates in spacetime. Black holes create the deepest possible curves. This is Einstein's field equation showing how mass and energy curve spacetime. Black holes represent the extreme limit of this curvature. There are different types of black holes based on their size and origin. Black holes come in three main sizes: stellar mass from collapsed stars, intermediate mass, and supermassive black holes at galaxy centers. Stellar mass black holes form from individual star collapses and range from 3 to 100 solar masses. Supermassive black holes exist at the centers of most galaxies and can be millions or even billions of times the Sun's mass. The interior of a black hole remains one of physics' greatest mysteries. As you approach the event horizon, time appears to slow down dramatically for outside observers due to extreme time dilation. Objects falling into a black hole experience spaghettification, where tidal forces stretch them into long, thin shapes like noodles. The difference in gravitational pull between your head and feet would become so extreme that you'd be stretched into a thin strand of atoms. Tidal forces are proportional to 1 over distance cubed, making them incredibly strong near the singularity. At the singularity, our current understanding of physics breaks down completely, and we don't know what really happens there. Stephen Hawking discovered that black holes aren't completely black after all. Hawking showed that quantum effects near the event horizon allow black holes to slowly emit radiation and lose mass. Black holes emit Hawking radiation, shown here as particles escaping outward from the event horizon. The temperature of Hawking radiation is inversely proportional to the black hole's mass, so smaller black holes are hotter. Through Hawking radiation, black holes slowly lose mass and can eventually evaporate completely, though this takes an unimaginably long time. Although black holes are invisible, we can detect them through their effects on nearby matter. Matter spiraling into a black hole forms a bright accretion disk that emits X-rays and other radiation we can detect. As matter falls toward a black hole, it heats up to millions of degrees and emits powerful X-rays that telescopes can detect. In 2019, the Event Horizon Telescope captured the first ever image of a black hole's shadow in the galaxy M87. Let's recap what we've learned about these cosmic giants. Black holes form when massive stars collapse under their own gravity after running out of fuel. The event horizon is the point of no return, where not even light can escape the black hole's gravity. Black holes create the most extreme warping of space-time possible, fundamentally changing the fabric of reality around them. Black holes push our theories to their limits and represent one of the most fascinating phenomena in the universe.